Today we're going to be talking about at-click event aggregation. So first of all, let's stop our problem. We have our client with a website on which he has a lot of different links with different resources behind them. And he wants to analyze how user performs, what kind of actions user does on his website. And for this, he can create its own system or go to big guys with set up systems, for example Google Analytics, and then all this work will be outsourced and client will just get ready analytics with aggregation of all kind of metrics. So focus our talk is clicks, and we will set up a system which is able to aggregate clicks around many hundred thousands of websites and show off them to analysts, data scientists, or whatever ad managers that's going to be using this information to enhance their own communication with client of websites users. So basic setup will be we'll get clicks from website. It will be routed to our API gateway. This is just like a general point for which we get a lot of different requests, and API gateway itself routes them to needed part of systems. So for us it will be some processing backend that's going to be dealing with clicks or other kind of events, and also we will have some separate backend generally with a lot of services that's going to be serving our like analysts, data scientists, and ad managers that wanted to view analytics more likely in some aggregated state. Alright, now let's move on to foundational system design. First of all, we need to discuss requirements. We need to aggregate number of clicks of ad in chosen time period, minute, hour, month, whatever. Return top K most clicked ads in chosen time period, and also apply aggregation filtering by different attributes. For non-functional requirements, we need to make our services reliable to give aggregation results that are good, and in general we're going to be using data for billing, because the more clicked ad is, the more money we can charge for it. Also we need to be resilient in the sense that downfall of our system will drop a lot of analytical services and break hell loose, because our clients cannot understand what is happening. They don't get any clicks, but why? Google Analytics show drops in every month, or user usages, what is happening, nobody knows. Also our own billing is going to suffer, because we cannot know how number of clicks for apps, and we cannot know which charges to make for every client. Low latency, because of a big flow of clicks, like we are Google Analytics basically, so we have hundreds of thousands of websites, maybe even millions. We need to make sure we are handling data flow pretty fast and aggregate it to show up to our client, to make sure he can act on info he gets from us. And of course scalability, because maybe we want to make sure that we can handle tens of billions of sites in 100 years to come. Alright, now let's move on to foundational system design part. So basically our corner system is API gateway, processing backend, and analyst, data scientist, and managers backend services. We're gonna cover processing backend and analyst backend. They're gonna drop to several services and data storages, and API gateway we just leave it at that, because it's just a general tool that we use as a point of indication that we have something here that gets at clicks. It had itself a rate limiter and many other useful things that I guess most of the apps need, most of the apps on a scale. Alright, let's focus on core parts that we need, and we will uncover them in the next part. So first you get yourself a click. Event occurred. Now you need to transfer it from API gateway like some routing service to something that's going to be deciding what to do with it, process it in some way. So first of all, we'll have event handler. It's going to get information about a click. It can be something in the form of, say, JSON or whatever, with @ID that got clicked. We also need some timestamp. It can be in Unix format. I'm not sure how many numbers it can go. I guess something like this in seconds. And some user metadata, or maybe just metadata, not only user, but it can be like service and so on. So just let's cover it like this. It will be some JSON also. It can be arbitrary big in some way. Of course, limited to communication between two web applications, so it not takes like a year to transfer terabytes of data. All right. Now that we get some JSON file, our event handler is gonna store it in some database or data storage even. It's gonna be not database but just a file on some hard or SSD. Alright, so basically what we do in our event handler, we get ourselves click events and we just flush them into this raw data storage database. We can do it in batches to make it more efficient. Of course, we will be at a problem of losing some data, but we will talk about it a little bit later. And generally, you can assume that you batch stuff and you may lose it for our basic system. But it allows you to lower your throughput through network and lower your loading on network. All right. So basically, after you dumped all this to raw data storage database, we need to think about what our user, in the form of some data scientist or ad manager or analyst, wants to get. In general, you don't really want to look at raw data because like add ID was clicked at timestamps this with metadata that, a lot of stuff. You want to know general statistics, maybe count number of clicks, for example, for specified ad ID you have in mind that you are tracking, for example, or you're running now. And this can be done via aggregation. So basically, we can allow to set up some aggregation schema. Let's for now assume that we set up aggregating for every minute, and period of time will be like for start of the end date up to its end. So basically, what we have in our aggregator is a function that's going to be taking all desired ad IDs, all of them, and aggregating by chosen group. So our ad manager X, for example, chose that he wants to see data in minute aggregation. So all his ads are going to be aggregated by minute. Aggregator is going to be taking this data from this database and running group by and count. It's pretty easy for lower load application to just do grouping. It can be just SQL database like Postgres, and you just run select and group by, and then after this you can put it in aggregation database. The result in the form of ad ID, count, and minute, I guess, something like this, or maybe some timestamps that's rounded to minutes. And now from this you can plot any kind of graphs that allow our ad manager to know like how ad progressing, ad click is going, and also create approximate aggregation by month, by hour, or he can just tell us to do it, and we will have also rounded aggregation by hours or rounded aggregation to months. We can do whatever our client wants. Alright. Also we have some viewer, of course, service that's going to be handling our add manager request, because generally you want to have some UI and not running SQL queries on database. So basically viewer is going to be hiding these SQL queries. It's going to be generating from our user through some UI. Alright, now let's cover it in more details and with ability to handle expected load. Let's refine our system. So first of all, we must put a load balancer to every service that's going to be experiencing big load, high throughput. That's what we've done here. Also, if we were to just directly pass data from AP gateway to our aggregator, we may come up with failure in aggregator. We can have some bugs in aggregator, we have cluster outages and so on. And it will be a good idea to have something as an intermediary between AP gateway and aggregator to store our events. And for these purposes, a suitable solution would be messaging queue. We are going to be using either Kafka or AWS Kinetic for these purposes. We can look also on other messaging queue solutions, but for this talk we are going to be focusing on that kind streaming kind of solutions, and we're going to be talking about a log file that's like underneath of Kafka, and why it would be a good idea to use it in our system. Alright, so for now we'll focus on part with offloading to data storages. So basically we could remove this flow from messaging queue to aggregator if we did not need near real-time aggregation results. But in our case we need it, and this requires us to create this like double passage, two passes. One pass is going to be storing raw data, and another pass is to like work on the stream, work on near real time, because we are getting events and we aggregate them right now, right there, and put them in aggregation database. So basically our viewer can check on near real times aggregation results. So our data always updating, and new statistics coming in, new aggregations created every minute, for example, depending on our time window we choose. And ad manager can readily check on what's happening with ads, how many clicks it gets. Also, we can show with approximate payment that he will need to be sent to our way, and he can decide if it's desirable or they need to stop campaigning at all. Alright, so basically from messaging queue we get events that are then transferred to the DB communicator service, which will be a service that is going to be transferring data to raw data storage. This flow is created for two purposes. One would be to allow customization of aggregation results. So basically our hot aggregation need to be predefined. We need to know time interval, like for example we are going to be aggregating every minute. We need to know aggregation function, like count number of ad clicks. Also you can add some dimensions, like maybe you want to have it by country, or maybe you want some specific kind of custom function that you want to run. We cannot predict what our clients need at systems that's currently running, because we have hundreds of thousands of them, and everyone wants something that may not many of them need. So for this purposes, raw data storage would be a good one, because it's likely they want their advanced analytics afterward. So basically they ran some campaigns and now they want to customize their analytical results, graphs and so on. Maybe they want to have a seconds refinement and see how events were going through seconds. That's also possible with raw data storage. Also, raw data storage is the shortest path from our events, and this allows for the most precise results in a sense, because we have like less failure possibility here. The less the less services you have, the less vulnerable they are to failures, outrages, and so on. And so we can afterwards I mean in a sense that not at real time, but say for example you aggregated for one day, and at the end you can run jobs to aggregate from raw data again, and compare with aggregation results that you got from near real-time solution. So for this we will have data reconciliation service that's going to communicate with raw data storage and aggregation database. Basically, data reconciliation need to have functions of aggregator, but it doesn't need to be near real time. So basically, it can take some time to calculate stuff and no need to be in rush. So there is like much less requirements to it to be not that advanced as aggregator is. And also we will need a separate logic of comparison with already crafted aggregation results from aggregation database. We'll leave it at that because it's not main topic, but I hope main idea is already communicated. Alright, now let's move on to this messaging queue that's created for aggregator failure, in a sense that we have some communication with database problems. If we were to remove it, not adding it here, if database communication fail for some point, aggregator will be overflown, as well as before with our IP gateway with data, and likely will run out of RAM. So we need some intermediary solution to keep in it. It also will be Kafka or OS Kinetic to keep our technologies in line, and it also have some benefits that we're going to be discussing a little bit further. All right, now for our database storages. For raw data storage, we can even use Amazon S3, so basically some system storage or hard drive or SSD, more correctly, to be said, basically storing files in some form that we want. Or we can use Cassandra database. Let's write it right here. Cassandra or OS S3 as an example for storage. For our aggregation, I believe Cassandra will be a better solution, because we need querying it. We need some rich query language to ease up on our request from viewers, so we don't need to implement this querying logic of different kinds in the back communicator. We just can use a rich language of Cassandra. It also can be some PostgreSQL, for example. But I believe scaling of Cassandra will be easier. And for our solution, we would need to resolve to some like upper service on PostgreSQL basis. I believe Green Plum or something like this would be a solution. Anyhow, I'm not sure it's the correct name, so I will just leave it at that. Let's say PostgreSQL cluster, something like this. You can really mitigate to any kind of database you want. It's only need to be really scalable and performant, in a sense that you will be running a lot of select queries, and you will have like flow of writes to it. So it needs to be handled writes very well and selects pretty good. All right. Okay, let's cover our part with aggregator separately. For viewer, it will be some service that's gonna be serving user interface. It will likely be like Google Analytics. Maybe you want to have some predefined requests. You don't want to write raw SQL. Maybe you have some kind of human language or maybe LLM even system here. So basically it's all about how we want to serve our customers on the side of ad management, data scientists or analysts. Like can be a lot of services here. As well, it's not a topic of our system because it will be like a system on its own, but generally something like this. All right. Also, we have these green arrows here to cover like special feature of custom aggregation request. So as I said, it might be that our clients want something specific that was not like written or is not delivered in our hot path or near real-time path. So basically we need viewer to put in request to aggregator. We can write this logic up to allow custom ways of aggregation and some way to like transfer logic from viewer to aggregator. For example, we can ask for other time step. We were aggregating every minute. Say, for example, you want every 5 minutes for some reason, and you can request aggregator to do this for your specific ad company, for example, or however you like it. So some subset of ad IDs that belong to you. Then aggregator would need to have a communication with database communicator and request some way of new aggregation that's going to be sent to aggregator, and then it can deliver it to aggregation database. Basically, you can have like separate aggregator, but in generally it will be the same kind of internals, maybe with some custom updates. So I don't see a reason to say that it is some other service. It can be just almost the same. So basically just for cleaning up stuff to allow for clear viewership, let's say that it will be something different, but internally almost the same. All right. Now that we covered messaging queues, database storages, reconciliation, viewer, let's move on to aggregator part. Go back a little bit and take a look here. What we have as a timestamp is basically event occurrence timestamp. Due to different kind of delays, for example, our client website delayed for reason of internet outage, or maybe our IP gateway was overflowed and could not process request. We do not get event at the time of its occurrence. We always have some delay, and most of the times it will be like small enough we can just not think about it. But at times it could be more than our time window. So basically we have a 1 minute windows, and if we get event from 1 p.m. 01 p.m. to 1:02 p.m. We have a lot of events happening at clicks in this interval, but we will get them only, say, 1 hour later, 2 p.m. to 2:02 p.m. will be time of some of them coming to us. There is no way we can aggregate them. We would need to wait 1 hour, and all this time we could not we would need to keep them in our aggregator somewhere on messaging queue, and need to remember to read them off, which creates like a lot of data pressure on all the parts of the system, basically. So it can work for low throughput system which don't get a lot of events, but for our Google Analytics like service it will be like a death sentence basically on our RAM and CPU for processing, I guess. So we need to trade off here, and trade-off will be that we will allow some kind of window relaxation. So we have our 1 minute windows to be 1 to 2 minutes, for example. So basically we have events of this kind we allow them to come from 1:01 to 1:03. So we aggregating of this minute. So we're going to be aggregating this minute, but we allow interval to be 2 minutes long. So basically some delays of 10 seconds or 20 seconds or even 1 minute will be accounted for. We will be keeping our data in messaging queue, and not reading it off before this happens to our aggregator, I mean, because our raw data, we always like taking it as it comes down. All right. Now this allows us to mitigate small delays, but big delays we can only mitigate on the level of raw data storage database. All right. Now that we have it here, also let's think about what we do with deduplication and where it might occur. So basically, if clients send us the same events over and over again, which is not a genuine one, they are just duplication, we can try and run on timestamps if they will be in milliseconds, for example. So add ID and timestamp could be keys for running deduplication, drop duplications. Or we can just wait. We can just assume. We cannot just assume that add ID and same timestamp is essentially a mistake, because even in milliseconds it could be that user like 2 users clicked, and we would need to go to metadata and like maybe use AP address, for example. I think these 3 keys would be sufficient. If we were not to get metadata, we could just assume something like some amount of users can click at the same millisecond, and this amount will depend on rate of our client website. So basically on like billions of requests to Google, it's really possible that maybe millions or hundreds of thousands of people click at the same millisecond, just because there is such a great number of people clicking on Google. But for some like a really local site that's like running on in some city of 100,000 people and not get a lot of viewers, we can assume that clicks not gonna happen. So you can devise any kind of complicated logic to deduplicate. But for now, let's just keep it as simple as running timestamps and some metadata keys to deduplicate our events right there. So on this, we will assume that IP gateway will get ourselves events without duplication, which may not be truthful, but enough for our example. So now, if our raw events are deduplicated, the only other place where duplication might occur is aggregation part. So our raw events have no duplicates. We just offload them to our raw data storage, and this flow is fully good, great, and not missing data, and everything is well and great. But for our aggregation, we might have a problem of duplicates if, for example, when communicating with messaging queue, we allow Kafka to deliver at least once. So basically there are 3 ways, I think, or maybe 4, at least once, at most 1, and exactly 1, I believe. Maybe there are some exactly once, at most once. So basically, at least once means that we can create duplication. So in messaging queue, there are no duplications, but when they come to aggregator, we can get ourselves duplication, because messaging queue can resend the same event just because it's not sure that aggregator got this event first time. At most once, this basically means that Kafka sends event and it doesn't care if you got it or not. It just sends it, so you either get it or you don't, which is not suitable for our case because we need to be as accurate as possible. So it can be used, I guess, because we have some raw data storage database, but I am uncertain that it will be well received. I guess we would need to trade off between how much we are ready to put in our system in terms of cost to make it more reliable on near real time, versus how much we are ready to spend. All right, and our the golden goose here, exactly once. that basically creates a communication between Kafka and our aggregator service. And in this way, it's more tedious in the sense that they would need to like exchange messages between each other. For example, Kafka sends you a message, then you need to send message that you received it. Then there is also a confirmation that Kafka receives that you communicated, that you got that message. So this is the solution we are going to be using, this like ping pong communication. So we are sure that you got exactly once our event, and now aggregation does not create duplications. Okay, so this flow will be solved by exactly once. All right, now how about aggregation with communication or sending of aggregated data? So now we have our aggregations that we are also not on duplicated data, so there is no issues. So aggregated data is good. Now we can create a duplication also on a path where we sending it to our data storage aggregation database. For this we also use Kafka, so we can rely on same way of exactly once mechanisms, which will allow us to communicate event only once. And through this we will achieve our deduplication also on this road. Alright, now let's talk about what aggregator can be. Generally it can be some MapReduce implementation. So because we have such a high throughput, we would need to run our summations, counts and so on many different nodes. And you can just use your own solution, or you can rely on already known to industry Flink or Spark streaming. We are not going to be diving deeper in every aspect of it because video is already too long in my opinion. If you want, you can ask questions down below. So basically what we have achieved, let's check on our requirements. We can aggregate in chosen period. We truly can return top K most click ads because we have our aggregation put in database, so there is pretty trivial to run a select that will get you top for our viewer. Also different attributes. I did not mention it truly because I just said that some metadata running around, but you can this metadata can be everywhere where our flow of data is going. So basically this is custom object, everything can go, and in database we can keep as a separate column with, for example, country, maybe some device, for example, mobile phone or tablet or notebook, whatever it could be. Alright, so basically this allows aggregation by different attributes. As discussed, reliable aggregation, we need to not lose data here and deduplicate it. I had a lot of extensive talk about deduplication, I hope it's helpful. And for not losing part, due to our scalability, load balancers and messaging queue, we achieve it. Resilience is also achieved through messaging queues because they allow us not to lose data, and load balancers allow us to handle high throughput. Low latency is achieved due to specifics of our usage as streaming path. I mean in a way that our Kafka basically presents itself as a log file which writes events, and then we just read these events from Kafka using our aggregation service, and then pre-aggregate and load off to viewer. This path allows us for low latency, because if we were to keep it in raw data storage and then offload to some job, it will require more time and more communication because we would need to communicate with data storage. All right. Scalability, yeah, pretty much covered. All right, thank you for being here and have a great day.